Welcome everybody to week 7 of the Cecil Gibb research seminar series. Let me begin by acknowledging and celebrating the first Australians on whose traditional lands we meet, and pay our respect and gratitude to elders past, present and emerging. So first of all, I'll hand off to Michaela, who will run through the housekeeping rules, and then you'll hear from Amy soon to introduce our fabulous speaker for today.
Hi everyone, thanks for joining the psychology seminar series. Just a few housekeeping rules. Just a reminder that the seminar is being recorded and will be available on the psychology YouTube playlist. Questions are welcomed and can be asked via the Q&A function or by raising your hand. If your hand is raised, I will invite you to unmute yourself and ask your question. Thank you for your attention, and I'll now hand off to our theme convener, Amy Dorr.
Wonderful. Look, it's my pleasure today to welcome Dr. Ben Grafton here to speak in our Research School of Psychology series. Now, Ben's from the University of Western Australia's School of Psychological Science, where he is co-director of the Rutherford Memorial Centre for the Advancement of Research on Emotion, aptly named CARE. Ben's research really helps us to understand how some of the biases that exist in cognitive processes can make people vulnerable to experiencing emotional disorders, and in particular anxiety. What I really love about this work is it gives us a nice example of how cognitive methods can provide insight into clinical disorders, including potential for interventions. And I think, really what this work is hoping to do is find ways to adjust these problematic biases where they have a causal role and that can be identified. So I'm super excited to hand over to Ben and to hear about some of the latest work he's been doing.
Thank you, Amy. As I was telling Amy and Erin and Michaela before, this is the first time I've done a presentation online. And I can see down the bottom of my screen thumbnails with Amy, Erin and Michaela, but I can't see anybody else. So I'm hoping people are there. And hello to you if you are. So today I'm going to tell you about research that's been going on for probably about 4 years now, which has been designed, or the intention has been to develop new tasks that could more reliably assess patterns of selective attention, bias patterns of selective attention. And so the first part of the talk will be about the efforts that have gone into that. But then the second part of the talk will be about how we've tried to capitalize upon the new approach that we've developed to try to address new questions. And I think that the way in which we've developed the new task is that it is a more reliable, more psychometrically reliable approach for assessing biased attention, and I think that's a really good thing. But the other benefit of the approach is that it permits us to present stimuli that would have previously not been possible with the conventional, traditional types of approaches for measuring selective attention. And I think that aspect of the research is something that opens up the field in ways that are going to allow us to address new questions that we wouldn't have been able to previously. And so I'm going to be focusing a lot on anxiety, but I would encourage anyone who's interested in cognitive bias to think about how these new approaches could be applied to the areas in which you work. And I think there is a lot of scope for using this across the breadth of research that investigates biased attention, but other types of biases in memory as well, interpretation bias, and how they contribute to different facets of psychological functioning, whether that be emotional functioning or consumption or whatever. And so even in my first slide here, I want to make this broad in the sense that different cognitive models propose that bias patterns of selective attention favoring the process of X information, whatever that is, play a key role in elevated vulnerability to Y. And so you can fill in the blanks depending upon what you're interested in. So for me, it's patterns of bias selective attention favoring the process of negative information play a key role in elevated vulnerability to anxiety. But if you're an addictions researcher, it would be biased attention to alcohol-related information play a role in elevated vulnerability to substance abuse. If you're someone who's interested in obesity, it would be processing of food-related information plays a role in vulnerability to obesity. Chronic pain, attentional bias to chronic pain-related information play a role in vulnerability to persistent pain. So, fill in the blanks for what's going to be what aligns with your interest. But the most common approach that is employed to assess biases in selective attention is the attentional probe task. So for those of you not familiar with the approach, starts off with a fixation point in the center of the screen, followed by 2 stimuli, and these are typically presented very briefly, 500 milliseconds, but sometimes a second, and sometimes even a little bit longer. And the information will either be X-related information or non-X. So if you're doing anxiety-related research, it would be negative information and, say, positive information. So you might have an angry face and a happy face, or a word like murder and helpful. If you're doing alcohol-related work, it might be a picture of beer and a picture of a soft drink or whatever. So following the presentation of that information, there is a probe, and participants are required to process that probe. In this case, it's to discriminate the identity of the probe. So it would be, is it pointing left or right? And on other trials, have the same thing, and the probe would appear in the location opposite to the target information. And so it's assumed in this task that you are going to be speeded to process the probe if it appears in the location to which you're attending. Therefore, you can get a measure of selective attentional bias by computing a different score, which reflects speeding to process probes in the location of the target information relative to the non-target information. So if you have an attentional bias to negative information, then you should be relatively speeded to process probes that appear in the location of that negative information relative to the probes that appear opposite to that negative information. So, as I was saying, cognitive models propose within anxiety that an attentional bias to negative information plays a role in elevated vulnerability to anxiety. And it's been shown across, 30 odd years now, that there's individuals with elevated anxiety vulnerability, whether that's because they're scoring high on a measure of trait anxiety, or whether that's because they have the presence of clinical diagnosis of anxiety, whether it's GAD, social anxiety, whatever, that they are speeded to process probes that appear in the location of negative information. Around about, I'd say, mid-2000s, some people started to raise concerns about the psychometric reliability of the probe task. And it wasn't probably until about sort of 2015 that that became something that was more prominent in the literature, and a lot of people were starting to comment on it. And the kind of thing that you'd see people say is that the internal consistency of the raw RTs, so just the raw probe responses, are quite high, above 0.8 typically. But the index of attentional bias that's computed from those raw RTs tends to have low reliability. I don't fully understand the maths behind it, but I've seen it argued that if the components of a different score are highly correlated, which is the case with the raw RTs that you get in probe tasks, then it will necessarily be the case that the reliability of the different score that you compute will be low. And when you actually look at the studies that have done this, they've shown that it has pretty poor reliability. So this was the first study that looked at it, Schmuckel back in 2005, with test-retest reliability and internal consistency, around 0.2-ish, 0.3-ish. Similar findings, again, about the same a few years later, and then people started to see this reported more in the literature. And basically, every now and then, you'd get someone reporting a slightly higher, slightly better reliability. Barheim, for example, got it up to 0.45. But across all the studies that you read, that the occasional higher finding is really it's not the norm. The norm is that you find that the reliability of the bias scores are low. So plenty of people has suggested that we need to try to develop new tasks that can more reliably assess attentional bias to negative information. Now, this next quote is not me. This was a quote from one of our reviewers who looked at the paper that I'm presenting on today. They said, rather than lamenting this fact, i.e. that it's got poor reliability, this paper presents a novel assessment method to remedy the problem. And that basically sums up where the literature was at, because everyone was saying, oh geez, it's got really bad reliability. I'd go to conferences and everyone would be talking about the poor reliability of it. But nothing was really being done about that. And so I thought this would be an opportunity to try and develop something, a new approach that can get around this problem. And so the approach that we came up with was that it's a slight tweak. So it's basically, rather than having a single probe that remains on screen that participants have to respond to, the new approach, which we call the dual probe approach, presents two probes, very briefly, only 200 milliseconds on a trial, and one in each location. Participants have to simply respond to the identity of the probe that appears in the location that they're attending to. So in this task, as I'll get to, we tell participants that it's the same probe, so it doesn't matter where they look, they'll be able to correctly identify the location of the probe. And to anticipate a question that someone might ask, we don't know whether or not it makes a difference if you tell people that it's the same probe or if you tell them it's different. The reason we did that was because we thought, well, if we tell them they're different, maybe they're going to start trying to look at the two probes at once. So if we just if we just tell them it's just the one probe, then that might reduce the probability that they engage in any attentional scanning. But we haven't conducted any studies that compare that instructional approach, so I don't know whether or not it makes a difference if you tell people it's the same if you don't. Anyway, so using this probe approach, this dual probe approach, we can get an index of selective attention to negative information simply by computing the proportion of probes that are correctly identified that appear in the location of whatever information you're interested in. So in this case, it's the proportion of probes in the location of negative information out of the total number of probes responded to. So initially what we thought we were going to do was compare, well, what we wanted to do was compare this new approach to the existing single probe approach. But what we recognized was that, and which we've argued in a recent paper, was that the problem with that approach would be is that the phenomenon of attentional bias, anxiety-linked attentional bias, is itself unreliable, and it can vary between sessions, within sessions, as a function of state anxiety, the type of stimuli you're exposed to, and so on. And so what we recognized was that, in principle, what you could develop is a new task that is going to be more reliable at picking up where people are attending to. But if the phenomenon that's being picked up itself is unreliable, then it's going to look like your task is unreliable because it's picking up an unreliable phenomenon quite well. So in order to get around that problem, what we decided to do is that we need to have a known pattern of a selective attention, and then we can contrast the capacity of our new approach relative to the established approach to detect that known pattern of attentional distribution. So the first two studies I'm going to report adopting that approach, where we know this is the pattern of attentional bias that people are showing, and can we better pick that up in a more reliable way with our new approach compared to the conventional approach. So I'll tell you a bit about how we went about doing that. So we generated an experimentally controlled distribution of attention. And in this case, it doesn't have to be multiplication symbols, it can be whatever you want, but that's what we went with. So it was attentional bias to multiplication symbols. And we did that by manipulating the frequency with which participants were instructed to attend to a multiplication symbol string. So what happened was that in both probe task variants, we had symbol strings. One of them was a row of multiplication symbols, the other was a row of addition symbols. And they were presented just like in a conventional probe task, very briefly for 500 milliseconds. And participants were instructed on each trial to attend to one or other of those strings, and the frequency with which they did that depended upon the instruction that we delivered. And what we're able to do was compare the capacity of the new dual probe approach compared to the single probe approach to both pick up this known variation in attentional bias and the psychometric reliability of these two tasks. And as just to preface where I'm going, what we found was that the single probe task was not as psychometrically reliable as the dual probe task and was not as good as picking up that known distribution. And then I'll tell you a bit about how we sought to extend that approach to look at whether or not we could develop a variant that was capable of picking up anxiety-linked differences in attentional bias in a manner that still maintained the reliability of the task. So, first study. We did this all online using MTech. And so we had our two different tasks, and we just counterbalanced the order in which the people got the task. So it was 2 blocks of 80 trials. And so the task looked something like this. The first 2 parts of the of the task were basically the instruction, where they said, you know, this is a trial where you're getting the add, and then you get the addition symbols, just to make sure participants knew exactly what they had to do. So they had to attend to the addition symbols on this trial. Then the 2 stimulus strings would appear, and the probe would appear 75% of the time, because you need to do that in order to actually get a measure of attentional bias in the location to which they are attending. In other trials, they would get the word multiply, followed by a multiplication string. Then the 2 stimulus strings would pop up, and the probe would appear in the location of the multiplication string, again 75% of the time. And so we can compute the index of attentional bias in the same way as we always would, but in this case just to multiplication strings. So looking at the speeding to multiplication strings relative to the opposite location. Then in the dual probe version of the task, it was basically, everything was the same except for the probes. So in this case, what we had were, the probes were grids. You can't see it. So they're 3x3 grids, like the 3x3 number pad on your keyboard. And so there would be a grey, they're not quite grey, but anyway, a grey square in the outer location of those grids. And participants simply had to say what the location of the little grey square was within that grid. The reason why we did it with grids was because we wanted the probability of an incorrect response to be low. So if it was the case that it was just if you just had a probe where it was, I don't know, a left and a right, and you have to say whether it was left or right, then if you're in the right location, obviously you get it right. But if you're in the wrong location and you made a response, then 50% of the time you'd still get it right. So we wanted one where the probability was much lower, which is why we had the 8 different possibilities here. So the task would look looked exactly the same. You get the multiplication, there's the thing pop up, and then a probe would appear in each location. It would only appear very briefly, and participants just had to say where was the location of the grey square within that grid. And so here we can get an index of attentional bias by looking at the number of probes correctly identified in the location of the symbol string out of the total number of probes correctly discriminated. And we got a distribution of attentional bias to multiplication strings by manipulating the frequency with which they got those instructions. And so every participant was assigned a particular bias score, which ranged from 100, so they always got the instruction to attend to the multiplication string, 0, where they got always the instruction to attend away from the multiplication string, meaning that they always got the instruction to attend to the addition string, and then a midpoint of 50, where half the time they were told to attend to the multiplication, half the time attend away from it. And we ultimately created a normal distribution of bias scores. So ranging, oops, that's the wrong, down the bottom there, that's actually the wrong scale, but anyway, it's the same thing. So basically that's ranging from 0 to 100 with a score of 50 in the middle there. So the results look something like this. With the conventional probe task, the split half reliability was basically 0. The retest reliability, this is actually an analog retest reliability is the best way to think about it. So basically we delivered the task twice within the same session, and so that's what we considered to be a measure of retest reliability. So it's not what would be conventionally done where you'd have it across, say, a week or so. So just think of that as an analog. But again, very low. And the correlation with the bias, so this was a correlation between the bias score that we computed for each participant and the bias score that we had assigned them. And as you can see, it's significant, but very low correlation. In contrast, with the dual probe approach, the split half reliability was 0.98, retest reliability 0.92, and the correlation with the bias that was known was 0.82. In other words, really, really good. So these findings suggest that the dual probe variant is better at picking up the bias, and it can do it in a more psychometric or reliable way. But we did recognize that it was possible that participants might have been adopting a different approach when they were completing the single probe task, because on that task, in order to compute a measure of bias, we had to have probes appearing in the location that they were instructed to attend to only 75% of the time. So we figured, well, maybe that would account for the differences in reliability between the two tasks. And the easy way to get around that is simply to have, basically to intersperse the trials in a way that meant prior to the presentation of the probe, participants had no idea whether it was going to be a single probe task, a single probe or a dual probe. So in a second study we ran, it was identical to the first, but the only difference were that we mixed up the trials, and probes were always now the 3x3 grids. And the results were basically the same. So slightly better split half reliability for the single probe variant. Retest reliability is not very great, and not clearly the correlation with the bias was terrible. In contrast, the dual probe variant was right up there again. So 0.97 split half, 0.92 retest, and the correlation almost identical to the first. I think actually, yeah, I do. So there you go, very consistent pattern of results that we get with the dual probe variant of the task. So the takeaway from this study, or the studies, sorry, was that again, we're getting the findings that suggest that the dual probe task can better pick up a known distribution of attentional selectivity, and it can do that in a highly psychometrically reliable manner. So then the challenge that we took on in studies 3 and 4 were to say, okay, now that we know this is better, is more psychometrically reliable, can we get it to can we design it in a way that's going to pick up anxiety-linked attentional bias? And the way we went about that was, I'll say, the conventional sort of approach, which is what you'd imagine people would do, was to take the task and simply, rather than having the symbol strings, now include images, in this case from the IAPS, which is a common approach across the anxiety literature. So the task looks something like this. You had the fixation point, then you would have a pair of images pop up, one negative, one not negative, then 2 probes pop up very briefly again, and participants weren't told, or they were told that they were the same probe. And again, all they had to do was indicate the location of the grey square in the probe that appeared in the location to which they were attending. And our measure of bias in this task was the proportion of probes correctly identified in the location of the negative information. And what we got with this approach was that the split half reliability was okay, not as spectacular as what we'd had previously. Again, same with the retest reliability, but there was no association with anxiety vulnerability and attentional bias. And so I actually tried this a number of different ways, but that would be a much longer talk. But what I recognized when I was looking at the literature, sorry, not the literature, at the raw data, was that as I was scoring it, I could always see that it kind of looked like some people were attending to one side of the screen. And then if you think about this task, and participants probably are going to do what's easiest, is that because the probe's only popping up very briefly, 200 milliseconds, the easiest way to complete this task is simply to look at one side of the screen and process whatever probe appears in that location. And so, anecdotally, when I was looking at the data, I go, I think people are doing that. So what we ended up doing was computing what we called a position bias score. And this was just the proportion of probes that participants correctly identified on the left side of the screen. And when you looked at the distribution, it was something like this, where away up that end of the screen, you had people who were showing a strong left position bias, and all the way down at the other end of the screen, that was people showing a strong right bias. So for whatever reason, people like looking at the left side of the screen. But basically, it was this position bias was overlaid upon any anxiety-linked attentional bias that could have been operating. And we argued was going to stuff up our capacity to actually assess the anxiety-linked attentional bias. So I did play around with different variants of how could we get this task to not have this position bias effect when you use these the traditional static stimuli. But eventually, what we thought was going to be a different kind of approach that might be effective was to instead use video stimuli. And part of the reason was that we thought that'd be minimally, just more attentionally engaging for participants. So you got this information, and you might want to be more likely to follow it rather than just look at one side of the screen. And so we developed what I'll call the dual probe, dual video variant of the task. Now I'll show you what this kind of looks like. So basically, had a negative video clip and a benign video clip. The clips were on the left side, right-hand side of the screen. They switch position every, I think it was 5, 6, or 7 seconds. And within each of those switches, the dual probes would be presented. And again, all participants had to do was indicate the location, the identity of the probe that appeared in the location to which they're attending. Now I'll give you, and the audio for each clip would come out of the corresponding headphones. So if the negative video was on the left-hand side of the screen, you'd get the sound for that coming out the left headphone, and when it switched over, the audio would switch over as well. So this doesn't actually work well unless you're not wearing headphones, but I'll just show you to give you a sense of what it's like. This is, I don't know the second movie, the happy one, but it's got Phoebe from Friends, and the other one is from Taken. The Taken video is a bit stabby and a bit shooty, so if you don't want to watch it, look away now.
Told you where we'd find you. What are you doing up so early? Just thought we'd get found. Breakfast! Jordan cereal's in there. You know that. I'm not the servant, all right? I have to lie. There's 2 meals a day. That's lunch and dinner.
Okay, now you may have been able to see probes that were appearing. I don't know, it might be too small, but so the probes were appearing every so often. And what we did was look at the proportion of probes that people identified in the location of the negative. Actually, the first thing we did was look at the position bias. And so we computed the position bias in the same way. And as you can see, once we use these videos, basically you get rid of the position bias. People don't show that anymore. And in terms of reliability, right back up there again in terms of split half reliability. Test retest reliability, not as great, but still pretty good. And we got a correlation between anxiety and attentional bias. So what we took away from this, well, from the whole thing, is that the dual probe approach is a more psychometrically reliable approach for measuring selective attention. You can use this approach to pick up anxiety-linked attentional bias, but it's probably not going to be the case that using static stimuli is the way to go, because what you get with that, and I'd say I've confirmed that across multiple studies, is that people just tend to look at one side of the screen. But you can eliminate that approach when you use video stimuli. And when you use the video stimuli, then you're capable of picking up the anxiety-linked attentional bias. So I'll talk a bit about, that was our first approach for looking at anxiety-linked attentional bias with the videos and with the dual probes. I don't think it was ever going to be the best approach, because I just don't think Hollywood movies are going to be the kind of stimuli, are going to be the best kind of stimuli for capturing anxiety-linked differences in attentional bias. And so I'll talk a bit about now of the kind of extensions that we've done to, with this dual probe approach in order to address new hypotheses. So this is what we call the talking heads approach. And this is where you can kind of let your imagination run free in terms of what you can do with this kind of, what you can do with videos and the type of hypotheses you can now address. So this is from my DECRA research, which is looking at, so we know that people who are high trait anxious tend to have negative expectancies about the world. Everything's going to be, they expect everything's going to be bad. And the point of my DECRA research is to say, well, why is that the case? What's driving the development of those negative expectancies? And so one hypothesis that we're testing is that it's because people have a negative, they have an attentional bias to negative information, or to information that carries negative implications for a possible future event. So the idea is that if you're, our expectancies will be driven, at least in part, by the information that we're exposed to about some future event. So if it's the case that your attention is captured more by information that has negative implications for that future event, then the expectancies that you're going to formulate are going to be relatively more negative. And consequently, if you've got those negative expectancies, then you're going to be feeling more anxious. Now, if you think about how people probably would have done that in, I'll say, the olden days, is that they might have got a typical probe task and they might have been sticking up, let's say, single words, and they might have been asking some people some expectancies about some future event. They would have looked at the association between them. But really, whether or not you can capture with single words the kind of information that people would really be attending to out in the real world about a future event, I don't think you could do that very well. But I think you can do that very well when you're using videos. So what we did in this kind of research, and we've done different studies, but this is an example where we did it with a job interview. So we told students that they're going to have to do this job interview at the end of the study. But before that, they're going to hear some information about what that job interview was like in the form of these videos. And some people are going to be telling them some negative stuff about this, and some people are going to be telling them some positive stuff about this. And what we did was we showed them these videos and look at the degree to which they attended to the more negative one. When we were creating the videos, we thought, well, what's the best way to do it? Should we script them? And we thought, well, we could, but maybe that's going to look a little bit unnatural, especially because what we wanted was to have students do the videos. So we thought what we should actually do is get students in from the same cohort of students who are actually going to be participating in the study, and we're going to expose them to the job interview task, and then we're going to have them talk about it from their own perspective. And we didn't want it to be completely just a free-for-all, so we did structure the videos somewhat. So what we had was that everyone had to talk about negative stuff, and other people had to talk about positive stuff. But we gave them categories of negative stuff and positive stuff that we wanted them to talk about. So for instance, in the negative, it was something like the feelings of anxiety that they experienced during the job interview. People were also told they were recorded during the job interview. So, thoughts that they had about how they're going to look on that video recording, and a couple of other categories. And for the positive, I think it was what a valuable learning experience the job interview was going to be, and how it was going to increase their confidence in public speaking. And so people recorded these videos, and these were the stimuli that we ultimately used in the task. And I'll give you a quick idea. Again, it's a bit hard to get the full experience with that when you don't have the headphones on, you can't get the left-right sort of thing happening, but I'll just give you a quick idea of what the experience is.
I've just completed the mock job interview task, and some aspects of the experience were really valuable. I was able to increase my confidence in public speaking because I was able to practice speaking and improvising under a pressure situation without any of the consequences that would normally be in that situation. There was no serious negative implication.
So not the full experience, but you get an idea of what it was like. So you can, and when you're doing it, you attend to one or the other person, and you can hear them quite clearly. So yeah, we had people come along, they were exposed to these videos, we measured their attention, and then we had them report their expectancies about the upcoming event, and we measured their anxiety, change in anxiety. And what we found in this study was that Attentional bias to negative information was related to negative expectancies. Negative expectancies related to anxiety vulnerability. Attention was also related to anxiety vulnerability, but importantly, we got evidence of mediation such that attentional bias was driving the expectancies, which were in turn driving anxiety vulnerability. So that's kind of, that is now an area of research that we're extending upon. And that was one of the first sort of talking head versions we've done. And now I realise I'm kind of starting to run out of time. So I'm going to show you a couple of other things briefly. So that's kind of anxiety stuff, and I'll return to that in a minute. But this is other extensions. So this is stuff that we've done with alcohol. And what we wanted to investigate in this study was, is it the case that people who have alcohol problems, too much drinking, do they attend more to alcohol-related information? So rather than using just the common sort of, here's a beer, here's a picture of beer, here's a picture of soft drink, what we did in this study was had alcohol ads and soft drink ads. So I'll give you a quick idea of that one.
Neil Patrick Harris, and this is Heineken Light, winner of the Best Tasting Light Beer at the 2013 World Beer Championship.
Okay, for time constraints, I'll stop it there. And I'll tell you a bit, basically the patterns and results that you got in this study were exactly the same as we got in this study. So this is another thing that you can do with the dual videos, which we thought, this is a study that we did with Melanie White. And so again, you can be creative in the kind of stimuli that you want to expose people to. So in this one, we had people, what we did was we created stimuli by using glasses, where it had the camera in the middle of the glasses. So it was basically a point of view shot. And we had people, I'll show you, pouring out the beer into a glass, and they would have got it out the fridge, and then they'd bring it up to their mouth, and you'd see the people, there we go, here's Chris, and he's drinking the beer, having a good look at it and whatnot. So that's yet another variant of what you can do with the dual probe task, dual video task. And in this study and the previous study, what we're looking at was whether bias drives beer consumption as a function of craving. And we got the significant mediation in this study again. So alcohol was driving cravings, and cravings were in turn driving beer consumption. And again, this is, you can do things that you wouldn't have been able to, what people would never have normally done with this new approach. And we've got extensions of this now. Rather than using alcohol stimuli, now we're using food stimuli. So we got I don't know why we keep doing ads, but we've got KFC ads, McDonald's ads, and then healthy foods ads, and we're looking at whether the degree to which you attend more to the junk food ads is associated with maladaptive patterns of consumption. So I want to quickly tell you a little bit about other extensions of this research, which probably would have never have got to had we not developed this approach. Because what we recognized was that maybe what's going on here is that people, what we're picking up is an attentional bias, but maybe all we're doing is just measuring the information that people choose to attend to. Because, and maybe what the literature this whole time has been doing just doing a really complicated way of measuring what is the information that people want to know about. That they intentionally want to choose to know. I want to know about this kind of information. So now we've got variants of the video task, where instead of looking at selective attention, what we're looking at is what we're calling choice bias. So I found some of the aspects of the job interview to be valuable and bad. And what people have to do is just simply click on the information that they want to hear about. So I'll tell you a bit about that, but I'll go back to a more conventional way of doing it. So when we recognize this, sometimes I'm a little impatient and I want to know the answer quickly. So rather than do it with the videos, which is going to take a lot of time, I did a variant of this task, MTurk, and I did this with people who had a fear of flying. So what they would get was this display at the start of the screen. You're going to get, what do you want to know about? Negative stuff or positive stuff about flying. And so people just had to click on the information they wanted to know about. So in this case, if you clicked on positive, you say, the chances of an engine stuffing up are very low. And even if it did, planes can operate with one engine. Versus if you sticked on the negative information, you'd say, turbulence is really unpredictable and it's really bad and it can move the plane around a lot. Isn't that horrible? And so what we looked at was just simply the proportion of trials on which people selected the negative relative to the positive information. And in the context of fear of flying, as it turns out, that those with the fear of flying choose to know more about the negative information than the benign information relative that's related to flying. And I guess if you did that, you can see why it would be the case that minimally that fear of flying would be maintained, but potentially also contribute to the development of fear of flying. And we've also done this in the context of negative expectancies. So again, we've done this with the videos as well, but to show you how you can still do this same kind of approach with more traditional stimuli. What we wanted was to replicate the same kind of methodological approach as we had with the video stimuli, but just do it in an online context. So what we told participants was that they're going to have to watch really nasty, or a video that contained nasty stuff about a refugee family who are having to make their way from a war-torn place, but also had some positive information that showed you, demonstrates the resilience of the human spirit. And what participants got in this study was they had the opportunity to read comments about this video from people who they were told had seen it in the previously. So the negative comments might be something along the lines of seeing footage of sick refugees at the camp, desperately fighting the urge to give in to death was gut-wrenching. Or they might have the opportunity to write positive comments like watching the children playing, laughing so gleefully together was a beautiful sight. And it was the same kind of approach where people just had to simply select which information they wanted to know about. And what we found in this study was that choice bias, so a greater tendency to choose to know about the negative aspects of this event, was driving the negative expectancies about the video. And that was in turn driving anxiety vulnerability, in this case, the degree to which anxiety was elevated across the course of the video, the lead up to when people thought they were watching the video. So choice bias, we never thought we'd end up there, but that's now becoming something that's filtering through all the research that we're doing now. So I guess it's, it's a new kind of bias. And we've got a whole bunch of studies now that are, some of them are looking at whether or not, what is the relationship between anxiety-linked attentional bias and anxiety-linked choice bias? Are we measuring two different things, or is this the same, or are we measuring the same thing but just in a different way? And we have other types of research that is again drawing upon this type of approach, again using the videos. And I don't really have time to talk about any of this. But I'll just start with the first one because I think that's kind of interesting, which is where if you've been exposed to negative stuff first, how does that impact upon your subsequent information processing? Or if you've been exposed to positive stuff first, how does that impact upon your information processing? And the idea is that, well, anxious people, if they've been exposed to negative stuff, they might be less inclined, let's say, keeping the choice bias, they might be less inclined to choose positive information subsequently. So they're not going to be consuming that information that might have the capacity to contradict the information they're initially exposed to. On the other hand, if you've been told positive stuff about something, anxious people might be more inclined to then subsequently want to know about all the negative stuff about that, which might, which does contradict the information they've been exposed to and might lead them to, in this case, develop expectancies that are going to be driving their anxiety. And we have a whole bunch of other lines of research now looking at expectancy updating. The idea that it's not the initial expectancies that we formulate that are going to be driving anxiety vulnerability, but it's going to be the way in which we update our expectancies. Because if you think about it, you only develop your initial expectancy once, but then you've got countless opportunities to update that expectancy in the light of new information, for example. We're also doing work looking at the expectancy experience gap, and that's the idea that it might not be our expectancies. This is more about what are the longer term implications for exposure to nasty events. And it might not be, expectancies might be important, but it might be the difference between what we're expecting and how life turns out that might drive subsequent anxiety vulnerability. So if you're expecting it's going to be really good and it turns out to be really bad, and so you've got a big gap there, that might actually be really important in driving a variation in vulnerability to anxiety. And this last one, if anyone's doing this kind of research, let me know, because since I've had a couple of kids now, this is my sort of, I've been pivoting my research to this sort of area, to postnatal mental health and just as a breastfeeding outcomes, because that's something we're able to do, and how expectancies might be driving variation in aspects of basically parenting. So if anyone's interested in that, let me know, because I'd be really interested in collaborating. So I'm fast running out of time, so I think I will leave it there. Thank you for listening, and let me know if you've got questions.
Excellent. If everybody would join me in thanking Ben, and if we want to put hands up or jump into the Q&A with any questions, and we've got a few minutes to kind of ask Ben about that fascinating talk. I can see Stephanie's already raised her hand in there. Michaela, do you want to unmute her, and we'll go from there?
Hi, can you hear me?
Yes.
Great. Thanks, Ben, for a really fascinating talk. Really interesting work on extending the measurement of attentional biases around emotion and anxiety. I was wondering what your thoughts were on perhaps the limited or mixed clinical success of attentional bias modification, and whether that stems from the psychometric issues in the dot probe and might be solved by some of the methods you talk about here today, or whether the perhaps disappointing clinical utility might stem from the fact that there's not the causal direction there between the bias and anxiety that's theorized. Okay,
so with respect to that issue, we distinguish between process and procedures. So what we have argued is that what you need to distinguish between process and procedures, because what people aren't doing, what people do when they look at this research is they ignore that distinction. And so they say, if you give people this procedure that's intended to modify the process of attentional bias, does that have an impact on clinical functioning? And the results look like that simply the delivery of these procedures does not generate beneficial therapeutic outcomes. But that's because you're just simply looking at the procedure itself. If you distinguish the process, so does changing attentional bias lead to positive therapeutic benefits, we would argue that the answer is yes. So when you look at those studies that have been capable of that have demonstrated a change in attentional bias, then the evidence is more consistent that that change in attentional bias does drive change in whether it's anxiety, vulnerability, or whatever else. So we've argued that the challenge in the ABM research and CBM research more broadly is to develop procedures that are more capable of evoking a change in that process, because when you do evoke that change in process, then you get the beneficial change in therapeutic outcome. So what we've been doing in this kind of research with the dual probe approach is to try to develop ABM variants of the dual video approach to see whether or not that can more reliably change attentional bias. But the other part of it is, I would agree that yes, the different aspect is that because we can more reliably assess change in attentional bias, then we can look at questions about whether the change in attentional bias mediates the change in clinical outcomes, for example, which is really not going to be, is not something you can look at with the traditional attentional probe task because it has such poor reliability. So I do think this type of research is going to have implications for the ABM literature, but because it's still in its infancy and we don't really know whether or not training variants of this approach are going to be capable of changing attention, and we've only got one variant of that to date, so we're going to have to wait and see, I think. So yeah.
Thanks for that. Sorry, I don't mean to monopolise the question time. Just one more follow-up to that. Do you think there's the risk, since there can be changes in anxiety that aren't due to treatment, And my understanding is that changes in anxiety can also lead to changes in the attentional bias. So if in the ABM studies you select participants who show changes in attentional bias, i.e. reductions in it, could you be just selecting the participants who are naturally changing in anxiety, and therefore it looks like they're reducing in anxiety rather than the mechanism being the change in attentional bias per se?
We don't, I wouldn't say we look at, we don't look at participants who have changed in attentional bias. Like we wouldn't be selecting specific participants who have changed in attentional bias. We would be looking at when you get the group differences in attentional bias, is that associated with change in, or do you get the change in the therapeutic outcome in that case? So I'm not sure if that answers your question, but so it's not a selection of people who are changing in attentional bias, because if you did that, then yes, all you would be showing is that you're getting association between change in attentional bias and change in outcome. So I'm not sure if that answers your question.
Yeah, it does. Thank you.
Okay.
I might jump in with a question if that's okay, Ben. Look, it was a wonderful talk. One of the things that I wanted to get at with this at kind of a pragmatic level is the duration of the task. So just wondering how long it takes to manage to get this nice, reliable task happening with the dual probe compared to, say, our pass dot probe type tasks.
The duration of the task is, so we have 1 minute videos. There's nothing special about any of this. So we've only done it with 1 minute videos because that's what we've done. And we've had 16 of them. So that's a 16-minute assessment.
Great.
I want to say that when we looked at on a study where we had the first, we did it in blocks for reasons I won't go into, but that was 12 minutes, and the reliability was again high, and that you were still picking up the bias after 12 minutes of assessment. So I think so. It's often shorter than what you get with a traditional approach. The challenge is not so much that, it's the creation of the videos, and that's what's going to be the thing I think that gets in the way of this probably becoming a more widely used approach, because it is more labor intensive. And so some of what we're doing right now is trying to create standardized sets of stimuli that we can make available to people. So we're doing them with social anxiety, GAD, trauma, those kinds of things. And we, so the idea is that might get around the hurdle of people having to create this for themselves, and then make it a more approach that's used more widely.
Wonderful. No, I love the ecological validity to it. I think it's something that plagues a lot of our cognitive research. That was wonderful seeing.
Yeah, and you can it's just kind of like let your mind go free. Like, how could you do this? With news presenters, we didn't do this because we thought we might run into ethics problems. But presenting vaccine-related information versus misinformation. There's just all sorts of things you can do.
Yeah, definitely some wonderful creativity there. Look, unfortunately, we've run out of time now, but Ben is at UWA, so anybody who's looking to ask further questions, I'm sure he'd be happy to get in touch via emails. Yep.
Sure. Yep.
And thank you everybody for joining us today. If you could just join me once again in thanking Ben for a wonderful talk.
Thank you.
Cheers, Ben. Thank you.
No worries.
Bye.
Bye.